Welcome to the deep dive. We're here to cut through the noise and focus on insights that really matter. Today, we are diving deep into securing web traffic in Kubernetes. Specifically, we want to unpack what TLS and SSL actually mean when you're using Ingress resources. Our goal is simple. Give you a clear, concise picture of how this works to protect your applications. Think of it maybe like putting an ultimate digital bouncer or maybe a secure lock right on your website's front door.
Right, and that's crucial because this isn't just some minor technical detail. It's really foundational. Whether you're building apps, managing infrastructure, or maybe just curious about web security, understanding how Ingress handles TLS is, well, it's vital. It has direct impacts on protecting data, on user trust, and importantly, on meeting compliance standards, which is a huge deal in these complex systems we build today.
Okay, so let's unpack that. We're talking about TLS transport layer security and its older sibling, SSL secure sockets layer. Fundamentally, these are cryptographic protocols. They take regular old HTTP traffic and secure it. They turn it into HTTPS. Now, in Kubernetes, when we talk about ingress resources, what role do TLS and SSL play there?
Right, so with Ingress resources, TLS SSL is basically the mechanism that lets your Ingress controller, that's the component doing the work, it can encrypt the communication. It secures the path between external clients, like someone's browser, and the actual services running inside your Kubernetes cluster. It's all about making sure that data stays private and hasn't been tampered with, data privacy and integrity.
So how does an ingress resource actually, do that? What are the key characteristics we should know about?
Okay, well, first and foremost is encryption. That's the core job. It scrambles the data, passwords, credit cards, whatever, so it's useless if intercepted.
Right, makes sense.
Then there's HTTPS support. The Ingress resource is how you configure TLS to enable HTTPS. You explicitly link a certificate to a host name, like your-app.com. That's what gives users that little padlock icon in their browser.
Ah, the trust signal.
Yeah.
And what about the certificates themselves? Where do they live?
That leads to certificate management. These TLS certificates, which are like digital IDs, they're stored as Kubernetes secrets, specifically the Kubernetes.io type. The Ingress resource just points to the name of that secret, keeps things tidy.
Okay, so secret holds the cert, ingress points to it, and the last piece.
Ingress controller integration.
Hmm.
Your controller, maybe NGINX, maybe Traefik, there are others, is the component that actually reads the Ingress resource.
Hmm.
It sees the TLS config, fetches the certificate from the secret, and then uses it to handle the secure connections, doing the actual encryption and decryption.
Okay, so bringing back our analogy, the ingress resource is like the security plan you give to your digital bouncer, the ingress controller. You're saying, okay, for this website, this host name, you need this specific secure lock, which is the TLS certificate stored in that secret.
Exactly. And the controller takes that plan, gets the right lock, the certificate, and stands at the door, making sure all the traffic going in and out for that site is encrypted and safe, just like that padlock icon promises.
That makes sense. What are some common use cases? Where would you definitely use this?
Oh, lots of places. The most obvious is securing a web application, like your online store at store.example.com with HTTPS. That's table stakes now. Or maybe securing an API service. If you have api.example.com, you need to protect the data flowing to and from it. And here's something really powerful. Supporting multiple domains, say app1.com and appy2.com, each potentially with its own TLS certificate, but managed by one single ingress resource.
Ah, okay. So how does that simplify things compared to, say, older approaches?
Well, think about it. Traditionally, you might have needed a separate load balancer, maybe even a separate public IP, for each site needing HTTPS, or complex manual configuration on a shared server. With Ingress, you define it all in one Kubernetes object. You list your hosts, point to their respective certificate secrets, and the controller handles routing and TLS for all of them. It dramatically cuts down on complexity and cost, especially as you scale or manage many different services.
Got it. So it streamlines things quite a bit.
Hugely. So if we zoom out, why is this capability so fundamentally important today? Why is it not just a nice to have? Because in today's world, especially with cloud-native apps, secure communication isn't optional. It's an absolute baseline requirement. TLS SSL, managed through Ingress resources, gives you a standard, deeply integrated way to achieve this security right within Kubernetes itself. It's fundamentally about protecting data, yes, but also meeting strict regulations like GDPR, PCI DSS, and critically, building and keeping user trust. A site without HTTPS just feels broken now.
Right. And let's break down those reasons a bit more. You mentioned data security.
Yeah, preventing attackers from sniffing sensitive stuff like logins or payment info, that's the most direct benefit.
And user trust.
That padlock icon. It's a visual cue.
Mm-hmm.
Users see it, they feel safer, more confident interacting with your site or app. Without it, they bounce.
Compliance.
Absolutely critical.
Hmm.
Many regulations mandate encryption for personal or financial data. Ingress Managed TLS helps you tick that box in the standardized way.
Okay. And you touched on simplified management.
Yes, using Kubernetes secrets for certificates is way easier than managing cert files scattered across servers. You can update them in one place, reference them cleanly. Plus, tools like Cert Manager can automate renewals right into those secrets.
Makes sense. And flexibility.
The fact that this works with various ingress controllers, NGINX, Traffic, Atria Proxy, others means you have choices. And these controllers often support advanced features like deciding whether to decrypt the traffic right away, TLS termination, or pass it through encrypted.
Okay, so those are the benefits. What happens if you don't use TLS SSL with your ingress? What are the real risks?
Well, it's pretty stark, actually. First, all your HTTP traffic is in the clear, plain text. Anyone positioned correctly on the network can potentially read it. Think sensitive data flying around unencrypted. Users will immediately see not secure warnings in their browsers. Trust evaporates instantly. Who's going to enter payment details on a site flagged as insecure? From a compliance perspective, you're likely violating regulations like GDPR or PCI DSS, opening yourself up to fines and legal trouble. And operationally, trying to manage HTTPS without Ingress TLS is a nightmare. You'd either need manual certificate handling on every service, or maybe spin up individual load balancer services for each thing needing HTTPS, which gets incredibly complex and expensive really fast, especially in Kubernetes where things change constantly. It just doesn't scale.
Right, that sounds pretty bad. Let's paint a
Absolutely.
picture with that e-commerce example again. Imagine shop.example.com running in Kubernetes.
Okay, so customers hit shop.example.com. They expect secure browsing, secure login, secure checkout. With an Ingress resource configured for TLS, you ensure that all interaction with the storefront happens over HTTPS. Their login details, their address, their credit card number, it's all encrypted between their browser and your Ingress controller. The controller, using the certificate specified in the Ingress resource, which it fetched from the secret, handles that TLS handshake automatically. It provides that secure connection seamlessly. And importantly, you don't need a separate, expensive cloud load balancer just for the storefront's HTTPS, another for the API, another for the admin panel. The single Ingress controller can manage TLS for all of them based on that one Ingress resource definition, routing traffic securely to the correct backend microservices. It's about consolidation and automation.
That really clarifies the practical value. Okay, so we understand the what and the why. Let's get into the how. How does this actually work under the hood? How do these secure locks get configured and applied in the cluster?
Right, it's a pretty neat workflow when you break it down. It involves a few key Kubernetes objects working together. First, you need a TLS certificate. You get this from a certificate authority, like Let's Encrypt, often automated these days, or maybe you generate a self-signed one just for testing. This certificate consists of a public part and a private key. Crucially, you store both of these pieces together inside a Kubernetes secret. And not just any secret, it has to be the specific type, kubernetes.iotls. Let's say for shop.example.com, you'd create a secret maybe named shop-tls.
Okay, so step one, get the cert, put it in a special TLS secret. What's next?
Step 2, you define an ingress resource that uses this secret. In your ingress YAML file, you'll have a TLS.section. In there, you specify which host names this TLS configuration applies to, like shop.example.com, and you tell it which secret holds the certificate, referencing shop.tls by name. This same ingress resource also defines your regular routing rules, like traffic for shop.example.com should go to the shop service. So you're linking the host name, the TLS cert, and the backend service all together.
Got it. Define the rules and link to the secret. Step 3.
Step 3 is having an ingress controller running in your cluster. This is a deployment itself, like the NGINX ingress controller or traffic. This controller is constantly watching the Kubernetes API for ingress resources. When it sees the one you created for shop.example.com, it reads the TLS section. It knows it needs to handle HTTPS for that host, and it fetches the certificate and private key from the shop.tl secret you specified. It loads this information and gets ready.
Okay, the controller is armed with the certificate. What does it do with the traffic?
Good question. That leads to step 4, TLS termination or pass-through. The controller usually performs TLS termination. This means incoming HTTPS traffic hits the controller decrypts it using the certificate's private key, and then it forwards the traffic usually as plain HTTP to your backend service, like shop service. This is common because it offloads the TLS work from your actual application pods. They just handle regular HTTP.
So the encryption stops at the controller. Is there another option?
Yes, there's TLS pass-through. It's less common for typical web apps, but sometimes needed. Here, the Ingress controller doesn't decrypt the traffic. It sees the encrypted connection request and just forwards the encrypted packets directly to the correct backend pod based on routing information like SNI. The backend pod itself must then be configured to handle TLS decryption. You might use this if you need strict end-to-end encryption all the way to the pod, maybe for compliance, or if the pod manages its own specific certs.
Okay, termination is usual, pass-through is special purpose, and the final step.
Step 5. Traffic routing and security in action. So a user types https://shop.example.com in their browser. The request goes to your Ingress controller's external IP or load balancer. The controller sees the request is for shop.example.com, uses the certificate from the shop.tl secret to establish a secure HTTPS connection with the user's browser. If using TLS termination, it decrypts the request, looks at the Ingress rules, sees it needs to go to shop service, and forwards the now unencrypted request to one of the healthy shop service pods. The whole path from the user to the controller was secure.
Perfect. So let's quickly recap those essential pieces again.
You need the TLS certificate itself, the public and private key pair.
Stored in a Kubernetes secret of type kubernetes.iatils.
Yep. Then you need the Ingress resource where you define your host, reference that secret in the TL section, and set up your traffic routing rules.
And finally, the Ingress controller, the actual running software that reads the Ingress, loads the secret and manages the secure connections, doing termination or pass-through.
Exactly. Those are the key players.
So the core takeaway for you listening is really that using TLS SSL with Ingress resources is like, well, it is putting that strong, reliable lock on your website traffic within Kubernetes. The Ingress resource is the instruction manual telling the controller which sites need locks and where the keys, the certificates in secrets are.
Right. And the controller is the diligent security guard using those keys to ensure all communication is encrypted and safe. It simplifies managing secure connections immensely, builds trust, and keeps sensitive data protected across potentially many applications running in your cluster. It's really a cornerstone of modern Kubernetes networking.
And that really highlights the incredible value here, doesn't it? Integrating TLS and SSL directly into the Kubernetes Ingress model takes something that used to be quite complex, maybe even a bit arcane, and makes it straightforward. It becomes an inherent, almost automated part of your infrastructure definition. It's definitely a big shift in how we handle web security in cloud-native environments.
It really is. And that leads to a final thought for you to chew on. What does it mean for the pace of innovation when this kind of foundational security that used to be a major hurdle, needing specialized skills, custom scripts, manual renewals, when that can be managed so elegantly, so declaratively right within your standard Kubernetes manifests? Think about the developers, the ops teams. How much creative energy is freed up when they're not constantly wrestling with certificate lifecycle management or debugging complex load balancer TLS configs. They can focus more on building features, on delivering value, on solving the actual business problems. How does this streamlined, automated approach to security empower us to build even more sophisticated, more resilient, and ultimately more trustworthy applications in this cloud-native landscape? It's something worth considering.